Good afternoon, students. Welcome to Fluid Mechanics 2 video session. In the previous class, we started with a new topic, that is centrifugal pumps. So in this particular chapter, we are going to study about that how the centrifugal pump works, or what are the different components, and another other different uh, portions we are going to cover. Okay. So in the previous class, we discussed about the introduction to the centrifugal pump, that is what is centrifugal pump, and also that basic concept of working. Okay. Even the classification of pumps also we discussed, like rotodynamic pumps are there, positive displacement pumps, or it is also called as reciprocating pumps. And I already told your centrifugal pumps comes under radial flow pumps. So radial flow pumps means the concept, whatever it is there, I'm going to discuss. Then this is the diagram which is related to reciprocating pumps. And also we discussed about the um, like different classification of pumps based on different criteria. Like depending upon the type of casing, there are two types of pumps comes into picture. That is volute pumps or turbine pump, or you can call it as a diffusion pumps. Like that only depending upon the head. If you are like see the majorly the pumps are used to lift the water from one place to from lower level to higher level, so that whatever that height is there, or we can call it as a head. So if it is very less head is there, then we can call it as a low lift centrifugal pump. Or if you want to lift at some medium level, like medium lift, we can say. If it is the lift or height is more, then you can go for high lift pumps. So like 15 meter, 15 to 40 meter, more than 40 meters, like that. Based on that head, we can differentiate three types. Then liquid handled, how the liquid will be handled, like closed impeller, semi-closed or semi-open impeller, or open impeller. In this one, I already discussed, like in closed impeller, there will be a base plate and the crown plate will be there. Whereas in semi-open, only base plate will be there. There will be a crown plate will be absent. In open impeller, only the vanes will be there. There is no any base plate or crown plate. And number of impellers per shaft. So you know there will be a motor will be there. Motor will convert the electrical energy to mechanical energy. So that is mechanical energy. That is nothing but that there will be a shaft which starts rotating. So that shaft, because of that shaft starts rotating, this centrifugal pump will be, or impeller will be mounted on that shaft. Because of that one, even the uh, your impeller also starts rotating. So because of this mechanical energy, there is a centrifugal force will be generated, and that centrifugal force helps the water to lift from one location to another location. Okay. So like that, how many impellers are mounted on the shaft? Based on that one also, single stage, multi-stage pumps we can classify. And a relative direction of the flow through the impeller based, maybe radial flow, axial flow, mixed flow pumps are available. And also we discussed about the advantages and disadvantages of centrifugal pump, or we can say advantages of centrifugal pumps over some other types of pumps, especially the reciprocating pumps. See, the main important thing is uh, about the uh, what we can say centrifugal pump is its efficiency is more. It we can use it for lift the water or any other liquids for a higher level. All those things are there. Okay. Afterwards, the main important topic was like components of the centrifugal pump. So mainly there are four important components are there in centrifugal pump. There is first one is impeller, the second one is casing, and the third one is suction pipe. Fourth one is the delivery pipe. So if you take this entire what we can say arrangement of the centrifugal pump, so this portion, this is nothing but your the tank from where you need to lift the water from this tank to, you need to lift the water to this particular tank. Okay. So for that one, there will be a pipe will be there which is connected to the one end will be inside the uh, what we can say inside that sump, and another edge will be connected to the eye of the impeller. So this pipe is called as suction pipe. Okay. Afterwards, there is, you can see that there is a casing here. So this is a casing, and inside that white color, this thing is called as impeller. So basically impeller is placed inside the casing, and you can see another vertical pipe. So you can see call this one is a delivery pipe. So that means from this tank the water will be taken through suction. So it is called a suction pipe. It is going to reach it here in the casing, and impeller will keep on rotating like this. So because of the impeller, it is rotating. The water, whichever it comes to the contact with the impeller, the water is also starts getting rotated. Okay, it starts rotating. So as it starts rotating, its kinetic energy will be converted to the pressure energy. So it is going to rise like this. So this is the outlet. So like this, it will start and it will reach to the whatever the height you require. So this is called as delivery pipe. Okay. So this is how the impeller works. And see when this what we call this impeller starts rotating, there is a centrifugal force will be generated. I already told this one. So it will be acting away from the center. Okay, like this. That means it pushes the liquid to outside. So because of that one, the liquid will flow like this and it will go up. Because of this one, the negative pressure will be created at the center. Okay. So this negative pressure, because of that one, it sucks the water. So it sucks the water like this and it reaches here. So like that, once again, that water will be pushed away from this one. So this is a continuous process. Once the motor is on, its negative energy and negative pressure or negative head is created here. Because of this negative head, the water will be sucked inside the pipe and it will reach here. It will be pushed away, and this will increase its energy or pressure, and it will rise like this and it will be delivered like this. Okay. So this is the basic how the exactly what happens when you switch on the centrifugal pump, or how it works. ओके, इम्पेलर के बारे में हमने डिस्कस किया था. इम्पेलर में डिफरेंट टाइप्स है. शॉर्टेड इम्पेलर इज देयर. So the second one is a semi-open impeller is there. Casing, then volute casing is there, vortex casing is there, and also casing with guided blades are there. All these things we discussed. Then we came to third point, that is suction pipe. उसके बारे में, this is suction pipe, उसके बारे में बात किया. And one more important point was in suction pipe, the edge or end of the suction pipe, two things will be there. One is strainer, which does not allow the impurities or any solid particles to enter into the pipe. And there is a foot valve which acts in one-way direction. That means the water can enter like this. But when centrifugal pump is not working, the water will not come outside from this thing. That means वापस नहीं आएगा पानी. It acts like in one way. Sorry. ठीक है? So it will be somewhat like this. ऐसा समझो पाइप है. ऐसा रहेगा. समझो पानी अगर ऊपर जाना है, जब प्रेशर क्रिएट होता है तो ऊपर ऐसे जाता है, तो दिस पाइप ना, इट विल गो लाइक दिस. सो ये ऐसा है ना, तो ये ऐसा ओपन हो जाएगा, तो पानी क्या हो जाएगा, पानी ऐसा आगे फ्लो होना स्टार्ट हो जाएगा. जैसे ही ओपन होगा तो पानी फ्लो होना स्टार्ट हो जाएगा. बट वंस द मोटर बंद हो गया, ओके, वंस मोटर बंद हो गया तो पानी क्या करेगा, पानी वापस आना स्टार्ट करेगा ना, ग्रेविटी, तो वापस ऐसा आने करेगा. तो ये क्या होता है, अभी ये पहले ऐसा था ना, पहले नीचे से आया तो ऐसे ओपन हो जाता था. अभी क्या होता है, नीचे जाने के लिए ऐसे क्लोज हो जाता है. तो ये रहता है ना बीच में, तो वो क्लोज हो जाता है, तो मतलब पानी इधर ही रुकेगा. ये यूज होता है, मैं बताता हूँ. सो दैट इज द वर्क ऑफ फुट वाल्व. ठीक है, ओके. So that is about the foot valve. Delivery pipe is this one. Even that is also having delivery valve. That means you can control the how much quantity of water you need to deliver, all those things. Then this is the basic diagram. Okay. There is one more this thing is there. This is the head we are talking. This is suction head. That is, suction head is from the level of water in the sump to the center of the high this thing, high of the impeller. So this is called a suction head. And from the center of the eye of the impeller to the whatever the height you need to fill the water. So till that one it is called as delivery head. So suction head plus delivery head gives the total head of the centrifugal pump. Okay. So this is I think this much we covered in the previous class. Now we will continue with the topic. ठीक है. Hope आपको revision समझ में आ गया. Okay, let's start with the working of centrifugal pump. See, a centrifugal pump works on the principle of forced vortex flow, that when a certain mass of fluid is rotated by an external source of energy, it is thrown away from the central axis of the rotation, and the centrifugal head is impressed, which enables it to rise to the higher level. So that means what he's trying to tell is, what is the meaning of forced vortex flow means, uh, when a certain mass of fluid is rotated. That means when a certain mass of fluid is taken here and it is forced to move away from this thing, because once the vane starts rotating, okay, so you know once it starts rotating radially, the centrifugal force will be generated. Because of that centrifugal force, that water will be increase the pressure and it will be delivered. So this is called as forced vortex flow. So because of that one, it rises to the higher level. The water rises to the higher level. So now it is the centrifugal force acting on a fluid that makes it to the flow within the casing. So because of that centrifugal force only, it keeps on rotating here inside the casing. Okay? And the next important thing is a term called as priming. Okay? And see, priming is a very basic concept which you already know, which maybe most of the students, people are already done this priming thing, but maybe you don't know the exact word this is priming. ठीक है. सी आपको याद रहेगा, अगर समझो आप बहुत बार मोटर जब ऑन करने जाते हो तो आप एक नोजल रहता है, एक उसको ओपन करके पानी भरते हो. ठीक है. पानी भरने के बाद फिर से क्लोज करके, नोजल क्लोज करके फिर से मोटर चालू करते हो. या कभी कभी बोलते हैं कि लाइक घर पे बोलते हैं मोटर चालू करने से पहले थोड़ा पानी डाल दो उसके अंदर, पाइप के अंदर, देन यू विल स्टार्ट द मोटर. सो दैट इज कॉल्ड एज प्राइमिंग. ठीक है. सो टेक्निकल वर्ड फॉर दैट प्रोसीजर वॉट एवर यू आर डूइंग इज कॉल्ड एज प्राइमिंग. सी बेसिकली मैं क्या करूँगा, इसको पूरा ऐसे एक्सप्लेन करते नहीं बैठूंगा, इतना ही है. ठीक है. See, it is the operation in which the suction pipe casing of the pump and the portion of the delivery pipe up to the delivery wall are completely filled with the liquid which is to be pumped. So समझो आपको ये पानी को इधर से पंप करके इस ओवरहेड टैंक को पानी भेजना है. तो आप क्या करते हो, समझो इधर एक नोजल है उसमें, या इधर नोजल रहेगा, तो आप क्या करते हो, पहले इसको ओपन करके इसके अंदर पानी पोर करते हो. कितना पोर करते हो, पानी पूरा ये सक्शन पाइप में भर जाना चाहिए और ये इम्पेलर केसिंग के अंदर भर जाना चाहिए, एंड इवन द डिलीवरी पाइप में भी भरना है, बट अप टू द डिलीवरी वॉल तक. तो मतलब इस लोकेशन से लेके आई टेक सो ऑलमोस्ट लाइक, सॉरी, वन सेकेंड. sorry. ओके. पूरा पानी इतना भरना चाहिए. ठीक है. सो इतना पानी आप उसके अंदर भरोगे, तो इसको बोलते हैं प्राइमिंग. ठीक है. अभी क्यों भरना है, ओके. Sorry. See what happens is, see how the centrifugal, sorry, how this centrifugal pump works. जब आप मोटर ऑन करोगे, ठीक है, तो क्या होता है, जब ये रोटेट होना स्टार्ट होता है, ये जो इम्पेलर है जब ये रोटेट होना स्टार्ट होता है, सो बिकॉज ऑफ दैट वन जब पानी सक्शन होता है, मैं भाई बोला था नेगेटिव एनर्जी क्रिएट होता है, नेगेटिव हेड क्रिएट होता है, उसकी वजह से सक्शन क्रिएट होता है. जब ये सक्शन क्रिएट होता है, जो वो लिक्विड को ऐसा बाहर पुश करता है, ऐसे फेंक देता है, तो वो उसकी वजह से जैसे रोटेट हो रहा है वो भी रोटेट हो रहा है ना, पानी भी. जैसे बाहर जाता है ऐसे घूम के ऊपर जाता है। सो क्या होता है कि ये सेंटर पोर्शन पे सक्शन क्रिएट होता है, नेगेटिव एनर्जी क्रिएट होकर सक्शन, नेगेटिव हेट क्रिएट होकर सक्शन प्रेशर क्रिएट होता है। उसके वजह से क्या होता है, पानी ऊपर खींचता है। और जब ये खींचने के लिए पानी का कांटेक्ट रहना बहुत जरूरी है। समझ में आ रहा है? समझो, इमेजिन करो इधर पानी ही नहीं है, तो जो ये इधर नेगेटिव एनर्जी क्रिएट होने वाला है, इट इज वेरी लेस टू सक द वाटर, तो वो ऐसे खींच नहीं सकता। ठीक है। सो जब तक ये पानी, जो भी पानी आपको लाइक पंपिंग करना है, तो उसको अगर ऑलरेडी आई आई ऑफ द इम्पेलर में कांटेक्ट है, तो इट विल बी इजी फॉर टू दैट वन टू गेट सक। तो इसलिए क्या करना है, तो आपको पहले वोल्ट बोल्ट या इधर एक वॉल्व रहता है, उसको ओपन करके इसके अंदर पानी फिल करते हो। जैसे पानी फिल करोगे इधर आके ये पूरा भर जाता है। देन जैसे मोटर ऑन करोगे ये तुरंत रोटेट होना स्टार्ट होता है, तो पानी ऑलरेडी है इसके अंदर, वो भी रोटेट होना स्टार्ट हो जाएगा। जैसे वो पानी पूरा विथ फुल फ्लो रोटेट होगा, तो सेंट्रीफ्यूगल फोर्स क्रिएट हो जाता है। उसके वजह से पानी पंपिंग स्टार्ट हो जाता है, और इवन सक्शन प्रेशर भी ज़्यादा रहेगा, और पानी भी कांटेक्ट में है, तो वो कंटिन्यूसली पानी को सक करता रहेगा। सो दिस इज हाउ इट वर्क्स। सो दैट इज वाई द वाटर शुड बी प्रेजेंट इन दिस पाइप। ठीक है। तो इसीलिए हमको प्राइमिंग करना पड़ता है। सी अभी नाउअडेज दिस फुटबॉल है, तो फुटफॉल में क्या मैंने बोला था अभी, ये क्या करता है, पानी को समझो मोटर बंद कर दिया, तो इसके अंदर का पानी पूरा वापस टैंकी में चला जाएगा नीचे, अगर फुटफॉल नहीं है तो। इसलिए फुटफॉल रखते हैं, जो क्या करता है, पानी वन डायरेक्शन में जा सकता है, दूसरे डायरेक्शन में वापस नहीं आ सकता, तो वैसे मेंटेन करेगा। इसके वजह से फुटबॉल का क्या फायदा है कि डिलीवरी पाइप में, सॉरी सक्शन पाइप में हमेशा पानी रहता है, वो बाहर आने नहीं देता। इसकी वजह से प्राइमिंग करना जरूरी नहीं है। ठीक है। सो दिस इज द कॉल्ड एज प्राइमिंग। आप इधर देख सकते हो, दिस इज द नॉर्मल कंडीशन। तो आप प्राइमिंग किया तो ऐसा पानी पूरा भर जाना चाहिए, बाद में कंटिन्यूस पंप कर सकते हैं। ठीक है। सो ओके, so that is about the priming. So now let's see work done per second by the impeller as the fluid. There are some assumptions are there, जैसे for to find the work done of the centrifugal pump या impeller on the fluid के लिए, liquid enters the impeller I in the radial direction. The wall component, that is VW1 of the inlet absolute velocity V1 is 0, and the flow component, that is Vf1 is equal to Vn, and alpha is equal to 90 degree. So basically the first assumption is, since the liquid enters the impeller in the radial direction बोले तो center पे जहाँ पे rotate हो रहा है उधर पानी अंदर entry में आता है. So because of that one, the world component, so you already VW1, VF1, VR1, all those things we studied in the पहले इसी टॉपिक के लाइक ये सेक्शन में हमने पढ़ाई किया था टर्बाइन केस में, करेक्ट है. सो वेलोसिटी, वर्ल्ड वेलोसिटी, दैट इज एट वन, दैट इज एट इनलेट. ठीक है. सी VW1 नॉर्मली अब्सोल्यूट वेलोसिटी रहेगा, इधर मोटर भी रोटेट होता रहेगा, पानी भी रोटेट होता रहेगा, इसलिए रिलेटिव वेलोसिटी काम पे आएगा. सो ऑब्वियसली अब्सोल्यूट वेलोसिटी इज द ओरिजिनल वेलोसिटी, वर्ल्ड वेलोसिटी एक आता है, रिलेटिव वेलोसिटी. सो the world component, that is VW1 of the inlet, VW1 बोले तो inlet, 2 बोले तो outlet, is 0. ठीक है. VW1 is 0, and the flow component, that is VF1 is equal to V1. So because alpha is equal to 90 degree. ठीक है. So no energy loss in the impeller due to friction and eddy formation. Because of eddy formation or because of the friction, we are, there is no any loss is there, like that we are going to achieve. ठीक है. So that means we are going to neglect this friction and eddy formations. No loss due to the shock at the entry. जैसे पानी अंदर घुसेगा, because of it, whatever the shock is going to happen, because of this one there is no energy loss. वो भी हम negligible assume कर रहे हैं. Then there is a uniform velocity distribution in the narrow passage formed between the two adjacent weights. See, even the small things also you are going to keep it in mind. So that means whatever the energy distribution is there in between these two pans, ठीक है, like that. So all these things will be remain constant ऐसा. ठीक है. There is a uniform velocity distribution रहेगा. So वो हम assume कर रहे हैं. Okay. So there is a concept called as angular momentum. So if you want to find out the, if you want to talk about the force exerted or work done, so here there is a concept of angular momentum comes into picture. ठीक है. So समझो there is a component which is having a mass m which is rotating in this like this circular, इसमें rotate होता रहेगा. ठीक है. See where m is the mass of the object, so whatever the mass we are going to object we are going to take, that mass is m rotating with angular velocity omega. So whatever the velocity at which it is rotating, so obviously there is a tangential velocity comes into picture, and also angular velocity comes into picture. So omega is the angular velocity component, and v is the tangential velocity at any point. समझो ये velocity है तो ये angular velocity रहेगा, sorry, और ये रहेगा tangential velocity v. Now momentum of the object is given by, you know, the momentum. Momentum is nothing but mass into velocity m into v. ठीक है. So this is momentum हो गया. But what about angular momentum? Because there is a difference between momentum and angular momentum. So angular, see, momentum of momentum, sorry, moment of momentum, you know how to take moment, correct? Moment is nothing but the force into perpendicular direction. So moment of momentum is nothing but angular momentum. So angular momentum बोले तो क्या है, जो momentum जो भी है उसका जो moment निकालते हैं उसको बोलते हैं angular moment. So hence angular momentum is given by moment of momentum. So इधर momentum क्या है, m into v, and into perpendicular distance क्या है with respect to obviously center, that is the radius r. So m into v into radius, that is m into v into r. So angular momentum is equal to m into v into r. ठीक है. So now ये concept याद रखो. What is angular momentum? That is angular momentum is nothing but the moment of momentum. So that is m into v into r, or mv into r. So work done by impeller on water. So now we'll see the work done derivation थोड़ा check करेंगे. ठीक है. See the expression for work done by the impeller of centrifugal pump on the liquid flowing through it may be derived in the same way as for a turbine. मतलब turbine में आप जो भी equation like apply momentum, impulse momentum principle वो जब करते थे, the same way we are going for this one also. Only difference is that impeller will exert a force on water, work done by impeller on water in case of centrifugal pump. सिर्फ बेसिक डिफरेंस क्या है कि टरबाइन का जो वर्क डन है और इसका वर्क डन, तो अगर आपने याद किया तो टरबाइन में क्या होता है, पानी फुल फ्लो से आके टरबाइन को घुमाता है, मतलब टरबाइन को ऐसे धक्का मारता है. मतलब अगर आपने थोड़ा अगर याद रहे तो ऐसा पानी आएगा तो ये समझो ऐसा टरबाइन का प्लेट्स रहेगा, ऐसा वेन्स रहेगा, तो पानी ऐसे इसको धक्का देगा, तो इसके वजह से ये घूमेगा ऐसा, करेक्ट है. मतलब force is exerted by the fluid on the vane, but whereas when it comes to the centrifugal pump, करेक्ट है, पानी वेन को पुश नहीं कर रहा है, वेन्स दैट इज इंपेलर घूम रहा है, उसके वजह से फोर्स क्रिएट हो रहा है पानी के ऊपर, वो पानी को पुश कर रहा है अवे बिकॉज ऑफ द सेंट्रिफ्यूगल फोर्स, करेक्ट है ना. सो दैट इज द मेजर डिफरेंस बिटवीन द working of turbine and the centrifugal pump. So main difference is work done by impeller on water, correct? So the equation for work done by impeller can be obtained by drawing velocity triangle at inlet and outlet. Once again turbine case में भी आपने inlet and outlet velocity diagram या velocity triangle draw किया था, तो same way इधर भी आपको velocity triangle draw करना पड़ेगा. So then you can go for the find the work done. The liquid enters the impeller at its center and leaves at its outer periphery. Obviously, हम लोग ये assume करने वाले हैं कि the liquid enters the impeller at the center. करेक्ट है ना. आप देख सकते हो पानी सेंटर पे एंट्री मारेगा और बाहर से निकलेगा, फेरी से निकल के ऊपर जाएगा, राइट. See, you can see this particular diagram. ठीक है. There is you can see there is a radial curved vein. ठीक है. और ये रेडियल कर्व्ड वेन ऐसे ऐसे ये घूम रहा है, रेडियल है, ऐसा रोटेशन है इसका. अगर ये आपने एक वेन लिया, समझो ऐसा वाला ना, ये एक ऐसा लेके हमने वेलोसिटी ट्रायंगल ड्रॉ किया है, तो आप देख सकते हैं इसमें दिस इज द एब्सोल्यूट वेलोसिटी v1 है. यू कैन सी दिस इज आउटलेट, सॉरी इनलेट 1 है, दिस इज आउटलेट है तो इसको 2 दिया हूँ. ठीक है. एंड आई हैव ड्रॉन दिस टू टैंजेंट एट आउटलेट, एक टैंजेंट एट आउटलेट है, एक टैंजेंट एट इनलेट. ठीक है. So this is absolute velocity v1 है. तो और ये जाने के बाद ऑब्वियसली इसका दो कंपोनेंट में हम डिवाइड करते हैं. करेक्ट है. vr1 एंड vw1 एंड vw1 इज जीरो. मैंने हमने अजम्पशन में पहले किया था. सो देर इज रिलेटिव वेलोसिटी. ये भी घूम रहा है, अभी ये भी पानी आ रहा है, तो रिलेटिव वेलोसिटी जैसे ये बाहर निकलेगा तो रिलेटिव वेलोसिटी रहेगा. तो vr2, तो vf2 एंड v2. करेक्ट है. And you know VW2, all these things we already discussed, right? So this portion is VW2, this is U2, ये कैसा आया, what is U2, what is VW2, what is VF1, what is VF2, all these things we already discussed. So that's why I'm not going to spend more time on this particular diagram. But you can see this is the velocity triangle diagram for the your centrifugal pump car. Okay. So once again, the relative velocity inlet is making angle theta with respect to that line. Correct है. U1 का line को. So ऐसे सब diagram proper से लिखना है. The impeller have curved vanes on its surface. ठीक है. So obviously these are curved vanes on the surface. Now radius of curved vane at inlet and outlet would be different, and therefore tangential velocity at inlet and outlet would also be different. So obviously radius is different at inlet and outlet. That's why even the tangents also obviously it will be different. That is U1 and U2 will be different. So you can see U1 and U2 will be different. Whatever these things are there, U1 and U2 will be different. See, further impeller will exert force on water in rotational direction and hence, so obviously impeller is going to apply the force on water in the rotational direction. Because of that only centrifugal force is going to generate. See, force by impeller on water is equal to force into radius. ठीक है. सो ध्यान से सुनो, फोर्स बाय इंपेलर ऑन वाटर. करेक्ट है. इंपेलर पानी के ऊपर प्रेशर डालेगा या फोर्स अप्लाई करेगा. दैट इज नथिंग बट फोर्स इनटू रेडियस, एंड फोर्स इनटू रेडियस वी नो इट इज नथिंग बट टॉर्क. ठीक है. So now this torque can be computed by considering angular speed. So now our work is to identify this torque force or calculate this particular torque force. Torque force. So this torque can be computed by considering the angular speed. Okay. So once again, you are going to apply impulse momentum principle. Now using impulse momentum principle, torque is nothing but, so obviously for which force you are talking. See, impulse momentum principle is nothing but force is equal to rate of change of momentum. Correct. Huh? So we can see force kya hai? Torque is equal to rate of change of momentum, but here it is angular momentum. So rate of change of angular momentum, mv into r. ये भी हमने देखा है. So now water enters into the impeller radially at the inlet. For best efficiency of the pump, V1 is equal to Vf1, alpha is equal to 90 degree, and Vw1 is equal to 0. These are the assumptions we already discussed. Now let n is equal to speed of the impeller in rotations per minute. So n is the speed of the impeller, and d1 and d2 is the diameter of the impeller at the inlet and outlet. So obviously d1 and d2 is nothing but 2r. दो टाइम रेडियस को, that is diameter. d1 is nothing but the diameter at inlet. d2 is nothing but the diameter at outlet. Omega is the angular speed of the field, that is radian per second, and that omega can be calculated by using 2 pi n by 60, where n is the speed of the impeller. Okay. Then u1 and u2 is the tangential velocity at inlet and outlet. So all these things are written in this diagram, u1, u2, all these things. Okay. Okay, u1 and u2 are tangential velocity at inlet and outlet. That is, u1 is equal to w into r. Okay, if you are trying to find out u1, so w into r1, u2 w into r2. So you can see u1 w into r1, where, sorry, that is omega into r1. So what is omega? Omega, it is written as 2 pi n 60. You can say 2 pi n divided by 60 into r1. और pi n सेम रखता हूँ. करेक्ट है. 2 into r1. So 2 times radius is nothing but diameter. So 2 into r1, nothing but d1. So I written pi into d1 into n divided by 60. Similarly, u2 is equal to 2 pi n divided by 60 into r2. So 2 into r2, that is d2. So pi d2 n divided by 60. ठीक है. Now using impulse momentum principle, now you apply impulse momentum principle. Torque is equal to rate of change of angular momentum. So rate of change of angular momentum is nothing but change of angular momentum per second. So now you know final angular momentum minus initial angular momentum, all these steps same remains, divided by second. Then momentum is nothing but mass into velocity. So m per second बाहर लेके आते हैं, इधर mass per second. Then velocity बचेगा, that is final velocity minus initial velocity. So but here is what we are going to do is initial angular momentum minus final angular momentum. You can see angular momentum at inlet or initial angular momentum is equal to mass into velocity by second or mass per second, velocity in tangential direction at inlet. Correct, na? If you are talking about initial angular momentum, obviously we require velocity in tangential direction at inlet. So what is the initial tangential velocity at inlet? It is nothing but VW1. So mass per second is nothing but rho into Q into VW. So this is momentum हो गया. Angular momentum multiplied by radius. Angular momentum at inlet is equal to rho into Q into VW1 into R1. Similarly, outlet के पास same, you can say rho into Q into VW2 into R2. Same thing, rho into Q into VW1 into R1, rho into Q into VW2 into R2. But assumption आपको पता था कि VW1 is equal to 0 था हमारा assumption. So VW1 0 हो गया बोले तो angular momentum at inlet becomes 0. So force exerted by the impeller on water is nothing but only this one. That is torque is equal to rho into Q into VW2 into R2. That is angular momentum at outlet. ठीक है? So that is about the torque force. Now work done per second by impeller on water. So now we got to know the force. Now we are going for the work done. So work done is nothing but torque into angular speed. ठीक है? So work done per second by impeller on water is torque into angular speed. So torque क्या है? इधर है rho into Q into VW2 into R2. Angular speed omega. But R2 into omega is nothing but U2. ऊपर हम भी वो भी लिखा है, ठीक है? Omega into R. One second. So omega into R लिखा है. So we can write U2 instead of R2 into omega. You can write U2. That is rho into Q into VW2 into U2. So work done per second is equal to rho into Q into VW2 into U2. Now this above equation, this work done per second can be said that equation of power or at impeller. Equation of power at impeller. So now above equation can also be written as work done per second is equal to, see, rho Q, you know, W is equal to rho into Q into G, or W by G is equal to rho into Q. So rho into Q के बदले में W by G into VW2 into U2 लिखा, ठीक है? So now work done per second per unit weight of fluid per second is given by this one. Rho Q cancel हो जाएगा तो बचेगा सिर्फ 1 by G. This is not 2. Work done per second per unit weight is equal to 1 by G into VW2 into U2. So similarly, we can write that is per unit weight 1 by 2 into VW2 by U2. ठीक है? So same thing where Q is equal to volume of water flowing through impeller, B1 and B2, everything remain same only. So you check it out this derivation. Okay. Next we'll talk about the head of the pump. What are the different heads, all those things हम in detail में discuss करेंगे. ठीक है? Hope आपको समझ में आया. चलो next class में मिलते हैं.